also on the website that eventually can download them if you would like to. Let me briefly, a couple of housekeeping things before we get into the details. So I'm just gonna go briefly over a few things, how you can get involved, just briefly introduce ourselves, and then I'm going to introduce, of course, our two speakers who are the most important parts, of course. So let me just briefly introduce the hosts of the AI Frontiers and Finance webinar. So we have Paulina Wehrhoff, who is a PhD student here at Frankfurt School, who's currently visiting NYU. Birgit Frankenberg, she's the founder and also managing director of a Frankfurt-based consultancy company, which is called High Peak. My name is Sascha Steffen. I'm a professor of finance here at Frankfurt School, and the seminar is hosted here at our Center for European Transformation. Why do I doing it here? I think it makes a lot of sense, and I think three reasons are primary here. So one thing, first of all, it's a lot of fun. So this is one of my first reasons why I'm doing that, specifically to talk to so many academics working in these topics, talking to so many practitioners working on these topics, and then, of course, educational. Right? So the second reason, this is exactly where research is headed. So there's so much research going on that using AI in various forms today is no exception. And then the third one, of course, I think specifically, given that we are in a center for transformation, I think AI is probably one of the most transformative technologies that impacts how firms work, how they operate, their cost of capital, how they innovate. And we're going to hear a lot about this also today. How can you get engaged? So I would like to highlight two things. First of all, if you have any kind of technical problems, send an email here, aifrontiers@fs.de, and we can help you. Please also get engaged. If you have questions, thoughts, questions to the speaker specifically, we have a Q&A box. You can write them, your questions, your thoughts into this Q&A box. And if you see something that you like that someone else had posted, you can simply upvote it and we can see it. Start right away whenever you have questions, and we can immediately bring them specifically to Tania's and also Xaver's attention. So let me get right then into the topic here and introduce our two speakers. So we have, on the one hand, very happy to have Tania Babina here today, who is an assistant professor in finance at Columbia Business School since 2016. She's got her PhD at in North Carolina, and also next to her research affiliated with different institutions, the National Bureau of Economic Research, the NBR, but also the Center for European Policy Research, the CEPR, and many others as well. And her research spans a lot of topics at the intersection of corporate finance, innovation, labor. And she has a lot of, if you go on her website, she has a lot of work on entrepreneurship, big data, AI, and overall how this impacts firms. And today is not an exception. She's going to present her work on how artificial intelligence impacts firms' systematic risk. And then we have today our empirical or practical counterpart, so to speak, which is Xaver Kelbel, who has basically since the beginning an interest in education in AI. So he has a master's degree from LUISS in Rome, where he studied big data and machine learning. He has a master in an LLM, which he has actually from Frankfurt School, and he has worked for a long time in this area of AI, big data in various positions. Xaver, we're very happy to have you here as well. Before I hand over to you guys, I just want to briefly do a quick poll among our participants. So I'm going to stop my screen and I'm going to start a brick poll just to get an idea of what you think about today's topic. So we have a couple of seconds to actually do that. So let me start the poll. So the question is, what do you think is the primary effect of firms investing heavily in AI on their financial profiles? So we have a couple of responses. We have increased systematic risk. We have decreased systematic risk. We have no significant impact on systematic risk. And we have a shift in risk from idiosyncratic to systematic risk. And the last one, I'm not sure. So we have a couple of seconds until we close the poll, and then we're going to see how people have responded. So a couple of more seconds. I think most people already responded. So I'm going to close the poll. And I'm going to share the results. So can everybody now see them? Perfect. So, oh, Tania, so let me hand over to Tania and Xaver. If you see the results here, 32% says high an increase in systematic risk, and 24% not sure. So what's your takeaway? Is this what sort of in line with your expectations?
Yeah, this is very nice that there is kind of some people who think there could be increases in systematic risk, some decreases, and this is actually quite consistent how we, before we started the project, thought about potential effects of AI. I'll talk in a few seconds about like why there could be channels when you can actually have decrease in firms beta systematic risk, and why there could be increases. So this is, you know, it's an empirical question to try to figure out which way things go. And this is usually, you know, a nice research question to answer when you actually don't know ex ante what you're going to find.
Xaver, is this also your take?
Well, my take was completely different. When I first looked at the problem, I was like, of course, any type of investment in new technology should increase risk and return factors. And what we will find out shortly with Tania is that this is the beta increases even more for AI. And I read her very, very good paper and went through it and was like, all the way, I have to find a flaw with it. And I'm looking forward to now hearing it directly from Tania, because there isn't a flaw. And hopefully I can bring later some business insight, why the research is so valuable and what happens on the business side that justifies these results.
Perfect. All right. Then let me close that. Just another, just to highlight again, please put your questions that you have into the Q&A box. So we cannot do an active discussion here given the large number of participants. So please put it in your Q&A box, and then we're going to introduce your questions eventually. So Tania, now I'm going to hand over to you. The floor is yours. Thank you so much for joining. Looking forward to it. Well,
thank you so much for having me, Javier. Thank you so much for your time and such a positive view of the paper. We obviously like it, but we like it even more when other people like it. So let me share the slides. So as Sasha pointed out, my research focuses on economic impact of innovation. And a few years back, I got really excited and interested in studying the new technological wave, new innovation, artificial intelligence. This is a third paper. If you'd like to see more, go on my website. The first paper shows that firms use AI for product innovation, actually not for replacing workers. And second paper shows that firms that invest in AI hire more educated, high-skilled, very technical workers, as opposed to some of the predictions that economists have, predicting that AI is going to replace all skilled labor. So, that's why we do empirical work to understand what are the actual impacts of technological change, and in this particular instance, exciting new innovation of AI. And this is joint work with my wonderful co-authors, Anastasia, Alex, and James. And this paper, research question is trying to understand what are the market-wide impacts of artificial intelligence. Okay, who cares about AI? This was a bit hard to motivate 5 years ago before ChatGPT. Now it's easier. There has been explosion in commercial interest and investments in artificial intelligence way before ChatGPT emerged and kind of popularized AI among masses. Why is that? Well, AI technologies or research existed for a very long time, for more than 50 years, but the tools, AI tools, were not very good, and they were very expensive to implement at scale. What happened over the past decade or so, a bit more than a decade, there were supply side factors that made this technology much cheaper and much better. So things like rapid accumulation of data, digitization, you and I working with data generating machines in our hands, plunging computational costs, AWS and cloud computing more generally made training models and storing data much cheaper. And of course, there are major methodological breakthroughs. Now, when I say AI, I want you to think about how industry thinks about AI, which is three interrelated technologies: machine learning, computer vision, and natural language processing. And Gen AI is a type of NLP, if you will, that blends machine learning and NLP. Now, what do we know already about economic impact of this technology on firms? By now, there is already consistent evidence that firms that have invested early in AI already benefiting from these technologies in terms of growing sales, growing market valuations, growing market shares. And surprising mechanism that we find kind of happens across all sectors in all firms is this using of AI for product innovation, improving products, customizing products, or creating products. And let me give you a few examples maybe you can relate to. COVID-19 vaccines were developed with AI factory. So if you go on Moderna and Google COVID vaccines, how they developed it, they talk very explicitly how AI was helpful to expedite the development and production of the vaccines. More generally in drug development, AI is being used across the board for vaccine or drug development. AI helps to find better, faster potential molecules that are more promising. Now, think about computer vision built into the cars. All modern cars can see, can alert you, or even stop the car if there is danger, right? That's an example of improvement of a product, building in computer vision into the car. In financial services, a lot of financial services now are very customized to customer data using ML models, both on like borrowing side, but also on financial advice side. And you guys in Europe have, in many countries around the world, have policies like open banking that kind of allow you to share your personal data and customize financial products. So that's kind of the common theme across many different sectors and firms, how firms use AI. Now, what we don't know much about, and this is where this paper comes in, is what are the potential market-wide risks of these type of technologies? And we're going to focus on the risk that Finance 101 class tells you to focus about, and the one that investors care about is firm systematic risk. What is it? Why do we care about this? Why should you care about it? It's a type of risk that you cannot diversify away, right? If you invest in the market, S&P 500 or whatever market index you invest, you are exposed to the risk of the market going up and down. And if you invest in firms that move even more with the market, investors don't like that, right? Like if your stock market or your firms that you invested in crash when there is a downturn, we don't like that, right? We don't like that, and investors demand us compensation for this type of risk. And how do finance folks measure this type of risk? There is a very standard measures of the systematic risk using market betas. What is it? It's literally the covariance of a firm stock price with the market, right? If you move 1-for-1 with the market, your beta is 1. If you move more than 1, you are more systematically risky than the market. If you move less than 1, you are less systematically risky. And investors, the less the beta, the more investors like this type of stuff. Now, how do you measure your investments? Well, that's very hard, actually. We're going to reuse, because there's usually no administrative data, no real-time data. In the past, economic historians waited for like 50, 60, 70 years to measure, to get measures of some kind of like new technology adoption. Now, due to AI, we can measure AI, impacts of AI in real time. So this is what we're going to do. And our measures are going to be based on human-based capital that firms hire to implement their AI solutions. So I'll talk more about this in detail, but think like if a firm hires machine learning engineers, deep learning developers, they do something with, try to do something with AI internally. And it turns out, this measure turns out pretty well empirically. Now, why do we care about AI? We know that investors demand premium for systematic risk, and that affects directly firm cost of capital, right? Their investment, their employment, the capital allocation across firms. So it's really kind of fundamentally important variable to study. Now, back to our discussion earlier, that Satya asked us, he was like, well, what do we expect? So we actually did not necessarily know what we'll find. On the one hand, AI can reduce firm systematic risk. In fact, we tried to have a project to see if this happens in the data. Like, why is that? Well, fundamentally, AI is a prediction technology, right? You take structured, unstructured, tons of data, and you try to make better prediction about something, right? Whether it's next sentence or an answer to a question or stock returns, or for firms, it's very important to understand changes in demand conditions and market conditions. And what if firms use AI for better forecasting and understanding market changes? They can adjust much faster, right? If you adjust faster than the market, then your systematic risk actually goes down. And for any students that are interested in the research topic, we were not maybe smart enough to find good data to test this, whether this is an important channel. And if you can, I think this is like an excellent research for job market paper or something. Now, alternatively, we can potentially expect increase in systematic risk. And, one interpretation of increase in systematic risk is due to increase in downside risk. So when I was talking to a bunch of computer scientists, when I was trying to figure out like what AI is, what it does, and, like, I don't know, whatever, 5-6 years ago, they told me, computer scientists told me, look, one thing we're worried about is downside risk of these technologies, meaning, before firm A, firm B, does business somewhat differently. We have our own internal kind of ways of production, of product innovation, etc. But once, bunch of firms start relying on the same models, right? Same third-party providers like cloud. You might have these firms kind of crash when market crashes or something bad happens, right? Like a few months back, we had an outage of one of the payment companies, and like all the companies who relied on that payment provider were out of business for like days, right? So that's kind of risk the computer scientists kind of had in mind. And there is also excellent Financial Stability Board report, which kind of also talks about this potential increase in systematic and systemic risk in financial services, precisely because of kind of these arguments. Now, this was where my money was. I thought it was like, okay, I wrote papers where I found that AI is already good for firms. Let's try some, potentially find some dark sides of AI use, and like this downside risk is like very sexy and a potential unintended consequences of these technologies. But that's actually not what we find. We do find that there is increase in systematic risk. It's mostly coming from firms early on investing in AI and kind of creating potential investment opportunities, or economists call them growth options, that later might or might not pan out, right? Like more generally, when new technologies arrive that can potentially be broadly important, economists call them general purpose technologies, GPTs. Example, you don't know when this emerge, whether it's going to be big or not. And there are, a number of very nice theory papers kind of written about this, which is, when new technology emerges, firms invest to potentially create these opportunities, and then they either pan out or not, right? In case of AI exposed, it looks like they panned out. And why would firms that sits on a lot of these opportunities created through the AI be risky? Well, because there is the growth options. There is a number of very nice finance papers in top journals that kind of argue that these growth options typically can move more with the market, especially when market goes up, right? Like when market goes up, the payoff from the options more generally is positive, right? But when market goes down, there is no kind of effect because you don't lose money in the options exposed when market goes down. All right, so as I mentioned, what do we find? We find that firms' AI investments associated with increasing systematic risk. And this is observational paper, right? We have a large set of firms for whom we measure their use of AI, and we do the best we can to kind of address causality statements, but we don't have random assignment of AI to firms. Again, if you manage to find in a setting where you have that, that's like another excellent research type of project, especially if it's an interesting economic. Now, what's driving this? As I mentioned, we think that this growth option channel that AI investments create for firms. What are the evidence we have to support this? As I mentioned earlier, one of the predictions is that the increase in systematic risk in these betas should actually mostly happen when market goes up, not goes down. This is exactly what we find. It's mostly happening on like good market moves, not the bad kind of downside market moves. We also find that consistent with some learning about AI potentially being useful over this period, which is we use a period from 2010 to 2018 when this technology kind of emerges. We find that on days when there are more news literally about AI that could be like big and stuff, you have bigger kind of increases in beta, consistent with these growth options potentially being valuable, right? Like if the technology turns out to be valuable, then the options are valuable. If not, they're not valuable. Now, what else do we find consistent with firms that invest in AI becoming more like growth firms? Investing firms do look like more growth-like firms, and finance people have the standard measures of like how growthy the firm is by looking at GML factor. And we find that it's it goes in direction that suggests firms that invest in AI become more growth firms. Now, what we also do, we try to see which other mechanisms might not be necessarily explaining the results. Results are not due to mechanical increase in beta, due to investing firms becoming larger part of the market. Think of like NVIDIA, right? Like over the past 5 years, it's exploded from like almost nothing to now like being one of the biggest tech companies. And it becomes bigger part of the market, and maybe there's this kind of like mechanical movement. NVIDIA drives the market, not the other way around necessarily. We don't find that's the case. We also don't find that increased financial operational leverage drive betas up. Your standard finance 101 would predict like when firms are more levered in generally, whether financially levered operating leverage increases, their betas increases. It's not explaining the results at all. It doesn't necessarily look like in the data that the AI investing firms become more like tech firms. So, like Jimmy Dimon, which is the CEO of the biggest US bank, came out a few years back and said, we're not a bank anymore, we're a technology company now. And I'm like, oh my God, what is this guy smoking? Like bank, a technology company, like that's kind of doesn't make sense. But after you look how much indeed, financial service companies invest in technologies, including AI, like JP Morgan invested a ton in AI. Maybe he's right, but we don't find that's necessarily the case. We don't find overall increases total risk or cash flow volatility potentially driving these higher betas. No changes in AI investing firms' equity duration, which would also can push betas up. And finally, we don't necessarily find that the investors that potentially trade in these AI investing firms in and out kind of drive these beta changes. So what's exciting about this project, I think, is that this is the first paper to empirically link firm level AI investments and firm systematic risk measures. And we're not the first to think about this. As I mentioned, there are a number of theories and papers that try to argue this, that when new technologies emerge, you can have this increase in systematic risk through different channels, including growth options. But now we have the data in real time to kind of actually show that when within the context of like AI, which is a new exciting technology, that's what happens. And more fundamentally, I think this paper is like, in finance, we often don't think about where investment opportunities come from, right? Like most of our model, you like throw money at the wall and you get your returns back. We don't think about the black box of how the sausage is made, like how the process of investment opportunities actually done by firms. And this paper shows, look, these new technologies can be potentially used by firms to create investment opportunities kind of endogenously. So I think that's from like deeper economic level, that's one of the most exciting things to me, to unpack like how growth options of investment opportunities are created. Sasha, how much time do I have?
So I think Xaver also need like 10, 15 minutes. So
10, 15,
like,
okay.
like 10 minutes or so, and then we switch over into a discussion, and then we can introduce the other results as we go along, I think.
Awesome. So let me briefly tell you about the data, results. I already told you about some of the mechanisms that do not explain. So I'll try to go quicker. And if you have any questions, we can chat later during discussions. Now, data. The hard things about understanding the economic impact of new technologies when they arrive is that historically we don't have good data. Now with AI, we can build data on AI or something else, whatever you want, whatever context. Like Sasha and Paulina, they have very nice work on measuring firm all kinds of financial variables using AI tools in real time, like covenants, etc. So it's like very useful tool for actually building the data more quickly than we could before. Now, when I started this project, I tried many different ways to see how to measure firm level use of AI over time. Many did not work well, like 10Ks or conference calls or news about AI used by firms. They're very specific kind of reasons why firms and when the timing when this being talked to. So you can't really have entire history that's kind of like unbiased by investor demands or market demands or attention, etc. So the best way I found to measure, and this is by now more or less standard measure, we were one of the first in the world to kind of try this, is to see whether firm hire AI skilled labor or try to hire. You can try to do this with job postings, which I started with. And what's nice about it, job postings for each job that firms wants to hire, you can have list of required skills. Like conceptually, if they want to hire AI skilled labor, like that seems like they want to do something with AI. Now, the kind of concern with job postings is it's not actual workers that firm hire or not manage to hire, right? It doesn't give you the actual stock of workers at the time. And to solve this problem, I was very excited to convince now my co-author, James, who to bring this data on online resumes. He used to be a chief data scientist of a major company that kind of scraped all online resumes at a commercial scale, millions of people globally, and kind of structure this data to make money. But what's good for us, we can see who, like if you think about a typical LinkedIn profile, which is like one of the sources of the data for this Cognizant company, you have very nice history of where you worked over time, what you did, what's your title, usually description of what you did, the years that you were at different companies, etc. So you essentially can build firm by worker by year panel that solves that problem of capturing actual hiring, not demand. Now, once you have like, once you have like, I don't know, like billions and billions of records for these people, like, or job postings, like how do you actually identify what's AI skilled and what's not? And what most people did, and this is why I started, is have a bag of word approach, the old technology, NLP technology, where you come up with a list of skills that you deem as AI related, and then you search for them in, say, job postings. But the problem with that, when new technology arises, there's both type 1 and type error. You're going to pick some skills that are not necessarily purely AI, or you're going to leave some which are, you don't know that they're AI related, right? Because it's new, it's emerging, etc. Now, how do you solve this issue? If you stare at the data long enough, at job postings data, you might or might not realize, took me, a bit of time to realize this, that like job postings, the data can tell you which skills are AI related and which are not. Like, for example, if you look at snow removal skill, jobs that require snow removal never require knowledge of machine learning. Kind of makes sense, right? Like if you have a guy who shovels snow, like you don't need to have them to be as skilled as Javier in like LLMs and stuff, right? Now, but if you look at jobs, job postings that require deep learning, 86% of jobs posting also require one of the core AI technologies, which is machine learning, natural language processing, computer vision, right? So you can essentially measure from the data. Some skills can be very coincident or close with the core AI technologies, and some will totally unrelated to them. So we calculate for each required skill. There are like around 14,000 or 20,000. What is the share of job postings that have this coincidence with a particular skill and these core AI technologies? And that gives you, for each required skills, how kind of close or far they are to core AI technologies. And then you can take the ones that have the highest kind of score, the highest relatedness. We take a cutoff if you're above 0.7 or 70%, and you look at the list, which is reported in our first paper where we kind of introduce this methodology, kind of validate it. They all seem like, my co-author James, who's like leading computer scientist in the world, he looked at it, he's like, oh, this makes sense. This is great. So data tells you what highly AI skilled skills are and which are not. Now, once we have that list, so you think about like 70 or so AI specific skills, then we search in resume data, which is much less structured, to identify you as an AI skilled or not over time, right? What if your job title, job description, publications, or patterns contain some of these highly AI related skills like neural networks, TensorFlow, etc., machine learning, then we identify you in that particular year at that particular form as AI related. And this is quite important to have this dynamically within a person, because at the beginning of the sample, you'll see almost nobody is AI skilled, and then people train and become AI skilled. So you need to do it within a person. Now, once you have this panel, which is kind of like firm by year, by time, firm by worker by time, then we identify each person's AI skilled or not, each particular year at each firm, and then at the firm level, collapse that data to calculate each year what is the share of the AI workers that particular year. So it's very simple and intuitive measure. And our sample is going to be public firms from the US from CompuStat. And this is because we need to be able to measure firm systematic risk, which you cannot measure for private firms. All right, so once we have that data, so let me show you the patterns. This shows the share of job postings in red, or actual workers at firms in blue that AI skilled. You can see there's something happens around 2012, 14, especially like an inflection. You probably know there are some important competitions that kind of show these technologies to be quite much better now. You know, before Tania could identify cats in the pictures much better. Now AI beats Tania, you know. So those type of things kind of drove interest in the industry and showed use case and proof of concept. Now, what this shows growth in job postings by major industry sectors in the first half of our sample, which is yellow, and blue, which is a second half of the sample. What I wanted to take from this is, you can see there is increase in job postings across all sectors. Like blue bars is much higher than yellow, but this happens across many sectors, right? It's not just tech, which is typically information and professional business services. You know, AI adoption is everywhere. And by now, practically all public firms have some kind of AI investments. Okay, so let me give you the main results. I only have 5 minutes or so. This table shows firm changes in betas as a function of the changes in the AI workers. And betas measured with 2 commonly measured models. What this shows you is that there is increase in firm systematic risk in whatever specification you like, whether you do a lot of controls in even odd columns, in even columns or not. And the magnitudes are quite large. AI investments associated with increase in betas of about 20% of standard deviation and changes within firm changes in AI. Now, so that's our main result. There is increased systematic risk, and you can look at this for interest of time. I'm not going to go in details how we do this, but if you look over time, these betas kind of increase. At the beginning of time, they're very small, but as a function of AI, these betas tend to increase as there is more AI investments. Now, what's interesting is that this increased covariance is driven not just by AI investing firms now looking like tech firms. Like, it's not like JP Morgan now covariates more with the tech sector, which also drives you know, stock market returns. In fact, if you calculate JP Morgan's betas with respect to IT sector only, first 2 columns, its own industry, financial services, column 3 and 4, or all other sectors in column 5 and 6, you see there is like this increased covariance across the board. So the relationship is very ubiquitous. It's not necessarily driven by the tech phenomenon. Now, we can run some placebo tests by looking at other non-AI IT technologies. As we know, IT technologies emerged in the 90s. By now, this is like very well adopted technology. If you know, we try to see whether it's something about AI or IT more generally that's driving this systematic risk, and we don't find that to be the case. If you measure firm change non-AI IT workers, kind of replace the main independent variable, you don't find positive correlation even. Or if you do this with robots, you don't find, again, any results. So the point of this is not to show that like this technology, AI is special, kind of going back to my discussion said, like there are theories that suggest a lot of new emerging technologies can have this increase in systematic risk through this growth option channel. That is to say, during this period, when AI emerges and when the previous technologies already kind of had the effects, we find support for this kind of theories of growth options. All right, so very briefly,
I don't want to interrupt you, but I think this is actually a good point, because I think this is a key result at which we can hand over to Xaver and then introduce maybe the rest of the results when the discussion comes up, because I think there might be a couple of questions related to that.
Awesome.
Xaver, what's your first reaction to that? You're still muted, Xaver. Sorry.
Thank you, Tania. Yeah, I'm still like empowered, enlightened, and yeah, energized by your study. And I'm still really happy that we're looking at a special technology here. But on the other side, I'm also like a bit maybe not as, I wouldn't call it delusional, but I fought a bit more battles down on Earth with AI. So there's some things I want to make remarks on, or like maybe get the discussion and the whole focal point of how we use AI in a different direction. And this will also like I will also incorporate some of the questions that already have been asked, where people said like, how do we make better decisions, investment decisions, or strategic decisions with AI? And then I think the really interesting thing Tania said is how we look at the workforce, the AI workforce in general. And for me, I will structure what I'm going to say in 3 topics. Like I will look onto the path to AI to see like how does AI get into companies. I will look into what might be success stories and what might be the cost of ambition cases that represent our downside in this discussion. And then I will have a short view on what that means for the implications to our future from a business perspective. And I try my best to kind of lead the academic discussion as well, or give some inputs there. But let's start with how do we get to AI? And I think most of us see AI as this big thing that changes everything. And if we look at actual business models, I think it's like since 2 or 3 years, we have companies where the core business model is AI. These are AI native companies. And like they created something where I can put data in and they have a special adaptation of AI and give me a result. So they have AI from the beginning. And all the other companies use AI in corporate functions. And I would go a step further and say, even these companies that are AI native, that created an AI in their startup idea, they mostly have to use AI at some point at corporate function as well. If you want to use AI in your HR department, in your financial department, in your business development, wherever you use it, you will not start with AI in corporate functions in many cases, or it's still not the case. So I would put these native AI companies aside and would say like, everywhere we go, we will use AI in corporate functions. And then I come back to what Tania said, that if we use AI, we can make a faster adjustment to strategy, to business. But I would go a step back, that every time we use AI to predict customer churn, to streamline our hotline with a computer voice or whatever we do, the AI has to prove its added value, and the AI has to build trust within the lower part of the company, like with the people who use it, and then up the chain into management. So if I have like an output from an AI, I will cross-check it first. I will want to live and get to know the AI before I tell my superiors. So like the AI kind of creeps through the company up to the decision-making level, and not is in the company and makes the decision for possible new strategic decisions. So that's something we have to really look on. And yeah, that is also why we could like see the implication on the beta that Tania spoke about, that these are models. If I implement them, if I implement a technology like AI, it's not something proven. Like if I build a new model for customer churn, this either has an imminent benefit, and I can see in terms of crisis immediately that there's a new customer base that's churning, or that new customers are coming in from a source that I haven't addressed previously and that I can address faster. So that will give me upside better and reduce my risk. But if I don't have an immediate benefit, or my model doesn't apply to changing environments, then I have like dead cost. And then I have like unproven competitive advantages. And then people have the cost of the AI, but in terms of crisis, they won't rely on it and make the decision on their own. So, and that is like, we haven't, or we shouldn't speak about AI, but we should rather speak about all the different sectors where we use AI. Do we use it in HR? Do we use it for like sourcing new deals, sourcing new customers? Do we use it in like technology and like product design? Like wherever we use it, it will have different implications. And if we hire somebody with a skill set AI, we also have to look, and I will come later to that, at the skill set, human resources, or each other skill set that has to work in tandem with the AI. I will come to a short story with that. Like back in university, I was like really proud. Back in the day, WhatsApp still had an API, and I programmed an API on my WhatsApp that replied to people. Everybody was really happy. And my best friend wrote me like, "Do you come for my beer?" And like the chatbot I wrote said yes, because that was my standard answer to him. So what happened? Customers very happy, but I, the person, do not know. So this is something we have to look on. Is the human connection, human AI connection, valid in this point? And that leads me over to success stories and like non-so-success stories that we really have to identify in the future, or that I come from, like how to implement this. It's on the other hand.
Can I briefly interrupt this point before you start to the next? Because that is what you just described is interesting. So in the sense of how AI needs to have some sort of like has to be guided in a sense by some human decision making in a sense. Tania, maybe back to you, because there was another question also in the chat that kind of compared now AI investments in AI to other technologies in the past, other innovations, and asked what is so unique about AI, right? So why do we need these sort of safeguards now, but maybe we didn't need them earlier on? So what makes AI so special that you also see sort of these data impacts rather through AI rather than through other technologies?
Yeah, so there are AI, according to some of these theories that kind of we're alive for motivation, AI is not necessarily different in a core sense that it's used to create investment opportunities, products, right? Like how you make money or change business models, etc. It just before you might expect to find the same thing if you look during the 90s, during IT revolution, during the 80s, personal computer revolution, steam engine, like 150 years ago, wherever, it was, cars in the beginning of 20th century. It's just before we didn't have data to kind of show this in real time. Now it is, that said, I think it is very important to think about what are the economic properties of this technology that we did not necessarily see before, right? Like how is AI different compared to robots or compared to IT, etc. And I think it's fundamentally different because it's a prediction technology, right? In IT revolution, and it's you program, it's a if you have a software program, it's a set of steps. Here you have a capability for designing systems that are adaptive to data based on kind of the data that system receives. So it's much more flexible, which has many implications. So I think fundamentally it's a prediction technology, and like where predictions are useful, well, where we have uncertainty and where firms face uncertainty in a lot of different places.
Do you think that are the risks different then to you both? So you talked about potential growth options, you talked about potential risks. Apparently these risks are somewhat mitigated in a sense. I mean, this is at least what the results show. There doesn't seem to be downside risk, but
yeah, so far, like this is important caveat, which is like we'll look at the initial period during the emergence of this technology. It's possible that if we do have some kind of enormous crash risk going forward, that the computer scientist story might still realize. Maybe during the period we studied, it was just not as widely adopted that kind of to have this downside risk. And that's why you need empirical work, I think, because like ex ante you don't know, and you need to be open-minded in terms of what you find. But I want to follow up on something that Xaver said, which is like AI can be used to solve so many different problems and so many kind of different use cases. And I think it's really important to study not just kind of like market-wide or like broader kind of patterns of how AI kind of affects firms, workers, whatever, but also think about particular applications of AI technologies within, because they're so heterogeneous, right? Like, and where AI can cause harm in one setting, it might not cause harm in another setting. So like, I think we need to study more in different applications.
I think we can look at we spoke shortly about the steam engine and the internal combustion engine, and when we look back in the late 1950s, early 60s, people were dreaming about putting nuclear reactors in cars and planes, in vacuums, wherever, like they were going crazy. And I think it's similar with AI. We're currently at a situation where we have a technology that we think can be used anywhere. And other than nuclear technology that certainly wasn't able to be used anywhere, AI is quite good in doing a lot of things. And that means we have to completely rearrange our work streams. We have to rearrange our business, and we have to rearrange the people in our business. Like, it's easy if I have like a simple task and give that task to the AI, like in a call center or something that is easily replaceable. But then it will get more difficult when I go up the value chain. And then I have to maybe rearrange my whole business and have to remember like what Henry Ford said when he said, like, when I ask people, they ask for faster horses. So maybe we don't have to replace stuff with AI, but have to look at the business from a completely new perspective. And that is where we have the huge upside. And that's the most difficult part, because we cannot say, okay, we put like AI into the engine and it runs faster, like if you find a new additive to your fuel, but you have to tweak every nut and bolt in your corporation to make it work and to see where the potentials are.
I think this makes sense. Tania, maybe you have done this and I cut you off before you could present this, but what you said is basically the AI is beneficial on average. So there are these growth options, so to speak. But if you were to look at that from like between different industries, would you maybe get different result that some industries you maybe more like this downside risk would materialize, where in others it might more the upside risk, or is this not a plausible explanation?
Yeah, I mean, we look by industry, just run the same regression by major sectors, and like it's of course noisy sample is smaller, but it's mostly shows up kind of everywhere. I think a more interesting test would be to think about like which are the sectors that are more likely to be disrupted by AI, and kind of use that kind of split cross-sectionally. Like, you know, Google coming out with a paper, we have no modes, and like other now prominent search engine, like I love Perplexity AI, for example, coming after Google. So like is sectors where business models can be like majorly disrupted by this, you know, maybe newish way of using AI for as a business model, is how I pointed out.
No, I think that makes a lot of sense. I think, Xaver, you had a couple of other things you wanted to talk about before I cut you off. We don't have so much time left, but maybe I think we need to introduce one more thought before we can wrap up.
Yeah, something I wanted to just talk about is like what might be, like, where can we look at when we look at like what are the upside risks that we can like pursue, and what are the costs of ambitions? That's something I wanted to go through, and that leads back to what I said earlier, that we have to like see, are we just replacing small steps, small tasks? And I think that's something that always works really, really well with AI. If I identify the task with a feasible problem and just make it happen. And that builds the trust in the workforce to like, maybe the AI can do a bit more, maybe there are other use cases, and then it slowly grows into the company. Like there have to be some variables, right? There has to be, the data has to be right, the relevant APIs in the company have to be addressable. And of course, you have to have like sponsorship, not only from the management, but from the people who are working with it, especially in like cases that people that haven't worked with big data sets, usually like marketing, they are always open to work with AI because they work with big data sets and try to validate their data from day one since they've been working. Other departments like human researchers, suddenly they never worked with that. So you have to open up their minds and slowly get it into the whole corporation, the whole organization. So the skill force has to work. And Tania explained that she saw like the progression in how these LinkedIn profiles she looked on developed towards AI. And I think that's something we will see. I think in like 10 years time, we won't see somebody working in HR, working in investment without any of these keywords. So these keywords will creep in because people have to use it, have to understand who are their counterparts and where's the problem coming from. And to go to the cost of ambition, I don't think that too many people from the business side are listening here, but just to have a view on that is that, especially if we have sponsorship for AI from a management perspective, and we speak about how we often speak, we have to bring AI into the companies, we have to bring AI to Germany or whatever we say, is that the most pressing problems a manager sees or like a politician sees is not the problem for AI and not the problem where we can start with. We cannot ask, like there was one question in the chat, like how can I make good investment decisions? And I worked with that a lot and was searching for opportunities, was searching LinkedIn, so and I can find people who are just founding their new companies, for instance, or have new ideas. So I look somebody who worked at Goldman, studied in Oxford, and is now in this new company. So this is something I can do, but it cannot find the big thing. So I have to explain it. And I think this is what we have to do when we just talk about like day-to-day life has to be improved first. And when simple tasks are improved, then trust is built with the AI, and then everything goes up. Because otherwise I don't trust the AI, and then I go back to basic and say like, now I trust myself.
I think this is actually a very nice word to close the session on. I think we're unfortunately out of time, even though there's so many interesting things to discuss. I also have myself a long list of questions actually for Tania, based on her paper. But let me briefly, before we close, I just want to highlight that and this is a big revelation, so to speak, from today's session. We're going to continue our webinar series next year. And we have here the first 4 speakers for 2025. We're going to take a break in January, but then we're back in February, on February 11th, where Marina Niesner is going to present. And then I think we have a good lineup of speakers and very different topics across the year. So invite everybody to participate, engage. Everything is already up on the website. You can already register. And I think before we depart, first of all, a very big thank you to Tania, to Xaver for taking the time to be here and to present your work and your thoughts. And nothing left to say than happy holidays, everybody. Merry Christmas, Happy New Year. And we're going to see you next year. We look forward to it. Thank you so much for dialing in, and see you soon next year in 2025. Thank you.
Thank
you so much, Stefan. Tania.
Nice to meet you.
Marina.
Thank you. Happy holidays.
See you guys. Happy holidays.
Thank you.
Bye.
Bye.